Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson, sequence series, we're refreshing what you know of quadratic number patterns. At the same time also refreshing how to find the general term. It's one of those compulsory exam questions, whichever way you look at it, and it's 3 to 4 marks once you understand this. So this is extra marks you can get if you get used to solving it, and that means you're going to have to do at least 3 to 7 problems to get this into our heads. Right? So, determine whether a sequence is quadratic. So if you see me write SEQ, that's just my abbreviation for sequence. Quadratic. So if we have a constant second order difference, the rule Tn is quadratic. So key thing, we have to look for constant second order, and when you say it's quadratic, it's defined by the general term Tn equal an squared plus bn plus c. So here we have example 1, 4, 11, 22, 37 given as a sequence of numbers. If we subtract, always from right to left. So if I say 4 minus 1, I get the value 3. If I say 11 minus 4, I get the value 7. 22 minus 11 gives me the value 11. 37 minus 22 gives me the value 15. Alright? So that is the first time I subtracted, therefore it's called the first order difference. Difference meaning subtraction. And first because it's the first time. So you see the values we have there, 3, 7, 11, 15 are not constant, meaning they are not the same. So therefore we have to subtract the second time. Always right from left. So 7 minus 3 gives me 4. 11 minus 7 gives me 4. 15 minus 11 gives me 4. So the second time I've subtracted difference, second order difference, I got a constant value of 4. Therefore that is called my constant second order difference, and therefore this then is considered a quadratic number sequence. Alright? So we go further into it now. We need to understand how to find the formula. So before we find the formula, I'm going to show you how these items we use to find the formula, how we've gotten them. So if we have a constant second order difference, the rule Tn is quadratic. Right, so Tn equal an squared plus bn plus c. So the quadratic sequence always starts with the first term. I assume you know that. So to find the first term, instead of n, I write 1. So wherever I see n, I place 1. So that becomes 1 squared plus b times 1. 1 squared is 1 times a stays a. b times 1 is 1, or 1b plus c. So a plus b plus c equals term 1. So you see the a plus b plus c equals the first term of the quadratic sequence. So that is the formula for term 1. Alright? Then you see there, to get the first term of the first difference, right, or the first order difference, or the linear sequence, I'm going to say term 2 minus term 1. Gives me term 1 for the linear sequence. Term 2 minus term 1. So to get term 2, in the place of n, I place 2, so that becomes 2 squared, b times 2. 2 times 2 gives me 4, so that gives me 4a, 2b plus c. Right, so now there you see term 2 minus term 1, right from left. So 4a minus a gives me 3a, 2b minus b gives me b, and c minus c cancels. Right, so term 2 minus term 1 equals 4a plus 2b plus c minus a plus b plus c. So 4a minus the a gives me 3a. 2b minus b gives me b. And then c minus c falls away. So you understand now why 3a plus b equals term 2 minus term 1. Right, and for the last one now, I haven't now still gone in. For second difference, we'll just say 2a equal those two terms subtracted. Term 3 minus term 2, whatever value I have there, minus whatever value I get there. That's my second difference. They'll all be the same, so 2a equal to that. So to find the formula, we're going to solve from bottom up. So we solve from one variable, getting a. Then we can put a into the second equation because there's now two variables, two unknowns. So because I have a now, I am able to find b. And once I have a and b there, then I'm able to find c. There we have three unknowns. Right, so let's look at the problem. Right, so working on the same example, we had 1, 4, 11, 22, 37. 4 minus 1 was 3, 11 minus 4, 7. 22 minus 11, 11, and 37 minus 2, 15. 7 minus 3 gave me 4, 11 minus 4, 7 gave me 4, and 15 minus 11 gave me 4. So for the first term, a plus b plus c equal 1. For the first difference, 3a plus b equal 3. For my second difference, 2a equal to 4. So we're going to solve it in that order. So let's look how we solve it. So there 2a equal 4. Always divide by whatever's in front of a. So 2a divided by 2 gives me a. 4 divided by 2 gives me 2. 1 mark for correctly getting a. Now I'm going to use a in the second equation, which is 3a plus b equal 3. But a now is 2, so 3 times 2 would give me 6. Take 6 to the other side, it becomes 3 minus 6, which then gives me negative 3. So p equal negative 3. Right, now because I have a and b, I can now go to the third equation that says a plus b plus c equal 1. A being 2 and b being minus 3 plus c equal 1. 2 minus 3 gives me negative 1. If I take negative 1 across, it becomes plus 1. So 1 plus 1 gives me 2. So c equal to 2. Therefore, Tn equal an squared plus bn plus c. A becomes 2, b becomes minus 3, and c becomes positive 2. Right? Go to the next problem. Now determine the n term. The sequence 4, 9, 20, 37 is a quadratic sequence. So again, 9 minus 4 gives me 5. 20 minus 9, 11, and 37 minus 20, 17. Now, hope you've taken note. I'm subtracting right from left. No? Don't go say 4 minus 9. That's how we catch you out if we give you a negative sequence. 11 minus 5 gives me 6. 17 minus 11 gives me 6. So again, second difference, 2a equals 6. 3a plus b equal 5. A plus b plus c equal 4. Alright, so 2a equals 6. Divide by whatever's in front of my variable a. So 2a divided by 2 gives me a. 6 divided by 2 gives me 3. Now I can go to 3a plus b equal 5. But a equal 3. 3 times 3 gives me 9. Take positive 9 across. It becomes negative 9. So 5 minus 9 gives me minus 4. So now we have a as 3 and p as negative 4. So I can solve a plus b plus c equal 4. A is 3, b is minus 4, plus c equal 4. 3 minus 4 gives me minus 1. If I take minus 1 across, 4 plus 1, c equal to 5. Therefore, my equation now, Tn equal 3n squared minus 4n plus 5. And there we found the formula for quadratic. So this was just to refresh what was already taught to you in grade 11. Hope you enjoyed the lesson. Wish you nothing but the best. Please like and subscribe. God bless. Bye.